We'll go ahead and get started. Thank you, everybody, so much for coming out. The room is packed. Filter in where you can. My name is Nate Ebel. I am an Android developer at a small development shop called Pixite, and we work on consumer apps for creatives. And in today's talk, titled Automate All the Things, as you might expect, we're going to be talking about automations and different ways that we can automate various parts of our development workflows to hopefully make our lives easier, make development more enjoyable, and hopefully have more time and energy for the things that matter most to us as developers. And like I said, I'm an Android developer, so a lot of the examples in this talk are going to be focused on like an Android development workflow. But really the goal of this talk is to spark some ideas and maybe point you at some specific tools that are really fairly generic and can be applied to development types beyond just Android or mobile. So hopefully this will spark some ideas that you can take back to your teams and be able to think about ways to automate your workflows. And so I want to start off by just kind of framing this and think about why do we want to automate things in the first place? And when I asked myself this question earlier this year, my immediate response was because I'm lazy and developers are lazy often. We would rather spend days writing a script that automates something that maybe takes us 5 minutes, once a week. But beyond that, I think there's some really important things that can come out of automating our workflows. The first one, and maybe the most important, is that it allows us to consistently build the right thing at the right time. When we check in code, we want to make sure that we are going to have predictable results. We don't want to have a situation where it builds on your machine, but nobody else's, and you have to argue over who's right. We want to make sure that when we check that code in, we're going to get the results that we expect. We also want to save our time and energy for the real challenges and the real important and hopefully enjoyable work of being a software engineer. If you are like me, you probably don't like spending time in code review arguing over code formatting or styling or manually distributing builds to your beta testers. Those things can really start to suck up your time, and pretty soon you're wondering why you never get to code anymore in your day. So with certain types of automations, we can prevent that and give us more time to do the things we like to do, namely coding. And finally, one I think that can actually be quite important but doesn't maybe get talked about as much is automation can make our projects more approachable. And I think the best example of this is a developer that joins your team, and by making a simple commit and maybe a single merge into develop or master, they can release code on day one. And you can't do that if you have a really complex process for building and releasing your app. But if you have something that's very streamlined, where things are automated, builds and deployments are triggered automatically, and you have tools in place that kind of guide developers on your team towards best practices, then it makes it really easy to come in and be productive from day one. And this is the same whether it's for an internal team or maybe an open source project where you're trying to encourage outside contributors to come in and work with you. And before we dive into really the meat of the talk, I just want to point out that I have a lot of the examples from this talk in these couple of repos here. And in this talk, we're going to be focusing on kind of a development pipeline that's built on GitHub Actions, as well as some other tools kind of specific to Android, and some other scripts, specifically Danger. And that can all be found in this GitHub Actions Automation Sandbox repo. And I have another version that's exactly the same, except it's built on Circle CI as just kind of another example pipeline there. And then these slides will be found on SpeakerDeck if you're curious and want to check out any of this information after the fact. So let's really dive into this, and let's start thinking about what kinds of things do we want to automate. Now, I know the talk said we're going to automate all of the things, and unfortunately, we don't have time for all of that, and I imagine the people sitting and standing wouldn't want to sit here for that. So we're going to really dial that down into a few specific things, although we want to keep this enthusiasm for automation. So we're going to look at 4 kind of points in the development process that we can probably all relate to. We're going to start off by just kind of looking at a general automated build, being able to build things consistently when we check in code. Then we're going to look at how we can leverage our build to enforce code quality and some small automations that we can use to make validating that code quality easier for everyone on our team. Then we're going to look at the code review process and look at some ways that we can encourage best practices in code review and make that an enjoyable experience for everybody instead of a time sink, which is what some people think code review might be, and therefore avoid it. And we don't want to avoid reviewing code. And then finally, we're going to look at the deployment process and a few ways that we can automate deployments to get closer to a continuous delivery process in our teams. And through all of this, we just want to kind of keep this in the back of our mind. Where are you losing time, energy, or joy in your development processes, in your teams, in your projects? And just as we start thinking about that, maybe think of areas you want to revisit when you get back home. So first off, automating our build. We want to start here because this is kind of the first step. If we want to think about automation, having those consistent results is maybe the biggest immediate win, especially when going from an individual working on a project to a team, whether that be at a company or open source. And really also the build is kind of the hub for a lot of this stuff. Once we have an automated build, we can do things like assemble our project, check for code quality, deploy that project, educate other developers coming in on that. So it's really the hub, so it makes sense to start there. And if you're not familiar, we'll just quickly review kind of this idea of an automated build. But basically, you'll have some server, whether that's locally on premises or out there on the interwebs, and it is essentially taking some kind of configuration file. And in that configuration, you're going to be defining certain types of tasks. So in the case of an Android development workflow, that might be something like assembling your application, testing that, and then deploying that. And those tasks are very simple. And a lot of cases are defined using some basic YAML file. And if you are doing this not on premises or even on premises, but if you're doing this for kind of your standard project, you have a lot of easy ways to get up and running with an automated build these days. You have things like Circle CI, Bitrise, GitHub Actions just finally came online for everybody recently, CodeMagic if you're working with Flutter, and I'm sure you probably already have many ideas in mind and maybe a preferred provider that you like to go to help with your build. And so the idea here is that this process is going to be roughly the same depending on, or really regardless of which of these providers you're going with. But for simplicity's sake, we're going to focus on GitHub Actions today. And so if you're not familiar with GitHub Actions, obviously it's based on having your code in GitHub. And you can add a workflow using a YAML file. And then within that, you kind of define when that action will run. You define the steps that you want to run. So that could be assemble, that could be test, that could be deploy, things like that. And then once that is merged into your default branch, anytime those triggers are executed, you'll start building that flow. So let's take a look at an example of that. This is kind of like a hello world version of a GitHub action. But it illustrates kind of the key bits here. So the first thing is in the yellow box there, we have the file path here. So we can define these steps for our automated build within our project repository so that everybody that's working on it can see how this is done. And at that .github/workflows directory, we're going to create this greet contributor YAML file. Now, the next thing I want to point out is at the top there, we say on, and then we have pull request and issues. So this is where we're defining when this is going to happen. So automatically, anytime someone creates a pull request in our repo or creates an issue, we're going to run the steps below. And in this case, we're using this first interaction, kind of third-party action within GitHub Actions, which is very easy to set up. This was done with basically a couple clicks in the repo. But basically, this allows you to define a message that says anytime someone creates the first issue or their first PR, define what you want to say. And in this case, we end up with something like this, where we have a bot that's coming in and just adding a message to that PR, thanking them for contributing to the project. It could be whatever you really want there. The idea here is that we can basically tie into certain triggers to certain actions within our development flow, run some code, and do with that whatever we want. And I particularly like starting with this case just because I like this idea of thanking people for contributing or encourage them to contribute because I think it makes the projects a little bit more approachable, and hopefully we want to encourage people to be contributing to our projects. Now, a more practical example, particularly for Android development, but again, these steps would apply to pretty much any type of workflow. But in this case, we're going to have this workflow called build project. And here we want to really just build our Android application. So again, here we're going to define some steps. So the first step here is a generic one really for GitHub Actions, which is check out the code in the repository. And then in this case, we want to set up the JDK, which we'll need for building our project. And then down below, we're going to run the assemble Gradle task, which is just going to build our application for us. So really with those kind of few steps there, we now have a basic workflow to start building our application anytime we kind of check in code. And so once we've had these workflows added, we can find these once they're triggered within the Actions tab of our GitHub interface here. And this is similar whether you're working with Circle CI or Bitrise. There's always some type of interface here that shows you where these are running, and then you can click into those and see individual steps. So in this case, once we've created a PR, we can see that we are now running each of these workflows, and we're waiting for some status checks. And in this case, let's say our build and test project workflow fails. Well, in that case, we can take advantage of this idea of requiring status checks before merging. This is where we really enforce that concept of repeatability and consistency in our build. Once we have decided to require status checks before merging, once we get that failed build step, we'll see something like this in our pull request that basically says, you cannot merge this code because status checks were unsuccessful. So then that would force the developer to go back and fix whatever was broken. And we'll look at some ways later on in this talk on how to make that process a little bit easier. And then once they fix that, you'll come back and you'll get kind of the happy path here. Yay, everything is green, merge your code, and we can move on to more exciting things. So that's kind of the first step here, and it's probably a review for a lot of us, but it's really kind of the foundational piece of this, because now we have an automated build, we're going to get consistent results, and we can start to build off of this and add in new functionality. So the first place we're going to do this is in validating code quality. Now this can mean a lot of different things, especially depending on what type of development stack you're working with. So again, in the Android world where I'm most familiar, this could mean things like checking the code formatting, whether that's Java, Kotlin, C++. That could be running tests. That could be running the Android Lint tool, which checks for certain Android-specific quality checks. It could be looking at code smells or common coding conventions that you want to enforce in your project. Kind of whatever type of command line tool you might be using within your project to validate certain things about that, you could think of including in this idea of validating code quality in your build. So for all of these tools, at least the ones I'm familiar with, they all come down to roughly the same process. You're going to add and configure that tool for your project so it's checking the things you expect. And then you want to integrate that into your build script. So in this case, that would be that build project workflow we looked at. And then you want to report those issues so that you can actually make actionable choices based on them. So you can go in and fix those things. So in our case, let's say we want to validate the formatting of our Kotlin code in our Android project. We're going to do that with a tool called Katy Lint, which, if you're familiar with Kotlin, you've probably heard of before. And basically, this is just something we run from the command line. It's going to tell us whether or not our code is matching the Kotlin style guide. So in this case, again, in our build project YAML file, we've added this new step here. We've given it a name, so we know what it's doing, and then we write out that Gradle task. So now when this workflow is run, we're going to run that Katy Lint check command. So now, once again, if the formatting in our code is incorrect for some reason, we're going to have our failed build here. And this is a means of enforcing that everyone on the team is using the same kind of coding standards and style guides within the project, which in most cases is probably what we want, especially if it's an open source project and you have a lot of contributors. However, there is a problem here when you start doing this in practice. And really the issue is that failing a build requires time and context switching. If you putting the finishing touches on a feature and you push that off and then you go grab a coffee or something and you come back and your build, 5 minutes, 10 minutes, 20 minutes, however long it takes, it has suddenly failed and now you've wasted all of that time. So now you have to go and fix that code and push it again, and now suddenly you're spending a lot of time just waiting for things to build. So it would be great if we could avoid pushing things that we know are going to fail the build. That way we don't have to waste that time. So in this specific case, this idea of validating code quality, a lot of these tools we can run locally. So we can look at some ways to kind of tie the local checks in and automate those processes so that we don't fail our automated build. So in this case of checking our Kotlin code formatting, we have a couple options here. We could reformat the code using the IDE, so IntelliJ or Android Studio most likely. You could also run those code quality tools from the command line using the same commands that you would be using in your build. And then ultimately, we want to avoid pushing that code if those fail. So in the first case here, reformatting code using the IDE. This is pretty straightforward. A lot of us probably have that shortcut memorized. But there's a couple ways that we can make this easier for everybody on our team. And the first one is to store the style guide that you're using in the project so you can easily share it with everybody. So as soon as someone clones your repo, they'll automatically be up and running with the same style guide so that when they reformat that code, it'll be consistent for everybody. And now kind of a nice, easy way to do this is to basically add that code format settings within your project, customize it however you want, whatever your team agrees upon, and then update your git ignore file in your repository so that it starts tracking that, which in the world of Android, a lot of times that is not done by default. And so we'll look in the next slide of how we can make sure that that gets added to the project. And then finally, another small tip is to optimize imports on the fly, which I'll mention why that's useful in a bit. So like I mentioned, in the git ignore file here, we can go in and automatically tell it, ignore everything in the .idea directory, which if you're familiar with Android, fills up very quickly with stuff that we don't always understand what it's actually doing. But then there's some specific things that we probably would like to share with people. So things like code styles, file templates, scopes, or copyright information. These we can go in and explicitly tell our repository to track so that we can share them with everyone on the team. Once we've done that, we can actually check and track these changes as PRs like we would any other code. So this makes it easy to see why certain changes have been made to our style guide. And then lastly, I don't know if you've run into this, but me personally, within Katy Lint specifically, have found that the formatting doesn't always match the Katy Lint tool. So one thing that has been helpful with this is making use of Android Studio, which will optimize imports on the fly, which is one small sort of automatic thing we found that really improves the accuracy of that formatting and helps us pass our build more often when checking our Kotlin formatting. So this is all great. That can make sure we're not pushing code that fails our build. The problem with this now is that you have to remember to do all of this. And again, when we're sitting there coding away during the day, putting on a new feature, maybe we're thinking about what we're going to have for lunch or the next coffee break, whatever, it's really easy to forget to kind of run that shortcut real quick to validate the code before pushing that up. Now, thankfully, again, we can kind of automate this process to make it even easier. And we can do that by using Git hooks to automatically run these checks whenever we clean our project or maybe push a commit. Now, if you're not familiar, Git hooks are essentially just shell scripts that Git can execute in response to certain Git commands. So things like commit or push. So kind of conceptually, we could think of this as anytime you're about to make a commit, we could do a pre-commit hook that could do something, anything you want really, anything that you could script. More specifically in our example, we're going to look at a pre-push hook that can run our Kotlin formatting check for us. Now really all that looks like is this. It's a simple shell script that runs the Katy Lint check command, and then depending on the status, either reports back no formatting issues were found, and we'll go ahead and allow that push to the remote repository to happen successfully, or it'll report back an error, say there are code formatting issues that must be addressed, and prevent us from pushing that code, which would have otherwise broken our build and prevented us from merging that code. Now in this case, this is what that hook looks like when it's fully functional within our repository. And it has to be in this very specific format. It has to be within the .git/hooks folder in our repo, and it has to be named pre-push without any type of file extension. So this is how Git will actually recognize this and run it in response to these hooks. So all we have to do now is manually copy this over into our directory anytime we're setting up our project. But because this is an automation talk, we want to do better than that. So what we can do is copy this script into our repository directly, save it as an actual artifact in the repo. And so in this case, I've saved that to /scripts/githooks/pre-push.sh. There's nothing particular about that other than the name. That's just where I chose to put it. And it's the same script. However, now we're going to go in and add some Gradle tasks that basically know how to take that script that we've saved in our repository, copy it to the proper location in the .git/hooks directory, and then remove that file extension. So basically it takes it from our location into the location where it's actually useful to us. And then we hook these scripts into kind of our Gradle clean command. So anytime someone clones this repo and cleans it for the first time, this will automatically happen. So this makes it easy for a new developer to your team, or if you're just building your project again for the first time, to come in, clone the repository, build it, and automatically have this script in place enforcing these code quality checks for us. Oh, and sorry, last step here is then basically just applying this so that it actually hooks those tasks into your build. But so with that, like now we've really gone kind of full circle here where we have these checks, we're enforcing them on the remote server to really make sure that our source of truth is always adhering to these standards. But then locally, we've also automated this process of enforcing them for anybody that clones the project so that we aren't wasting that time on the remote server. And if you ever want to, there's ways to kind of bypass that. But by default, this is kind of a nice workflow. And as we've implemented this on our team, it's really helped us get into a groove where we're not failing builds. And if something fails, it fails locally where it takes 30 seconds to fix as opposed to maybe the full length of our build, 10 minutes, 15 minutes, whatever. So it saves us a lot of time. So now we have our automated build. We're ensuring that our code is adhering to the quality standards that we've decided upon. Now it's time to review the code. And this is my favorite part because I really like code review. I think it's really powerful. If you're not doing it, I encourage you to do so. And I think this is a place where we can automate some certain things that people maybe wouldn't normally think about, but I think really can improve the quality of code review and hopefully encourage people to really embrace that. So when you think about reviewing code, I think about a few things here. Think about validating the changes in our diff, making sure that we're fixing the right thing, creating the right feature. We might want to discuss approaches, compare, contrast things, and then we can also use it to learn or to educate others as we see how other people do it. Now, all of these are really valuable and really helpful to us, but they can quickly sort of get bogged down if we're running into issues like not enough detail in our pull request, or messy code, or we start arguing over conventions and formatting. It's really easy to start to get caught up in some of these minutiae instead of focusing on the core things. And so we're going to look at a couple ways to sort of get around that. And now these will be focused on kind of a GitHub workflow, but again, a lot of these concepts work with other issue trackers or code repositories as well. So in this case, we want to avoid pull requests that look like this. I don't know about you, but I personally don't think that this is a great pull request because it doesn't really tell me anything. Updates brushes is basically useless. And when you get a pull request like this, depending on your mood, this might just set you off on kind of a dark path where you're automatically unhappy about having to review this code, which then can impact your mood reviewing it. And that can just start to spiral into a situation where it's not going to be the most conducive use of your time, and hopefully you're not, or most likely you're not going to get as much out of that review as you could. So we want to avoid stuff like this, and instead encourage pull requests that maybe look something more like this. This has a lot more detail to it. It's got clearly defined sections. It's got some high-level bullet points of what's going on, some additional information to help frame the changes, maybe a checklist. So stuff like this really sets us up to have a more successful code review. And really, once we have that in place, then we can do those other things like discuss approaches and hopefully educate each other. So to do something like this, we can make use of GitHub pull request templates, which is essentially just a GitHub flavored markdown file called pull request template. And within that, we can add whatever sections we want. So this right here is the template that we're using at PicSite. And in particular, the screenshot section at the bottom here we have found particularly useful. Being able to tell the developer or project manager, whoever's looking at this PR, like this is what it used to look like and this is what it looks like now, that in itself is hugely useful and makes it a lot easier to go in and immediately understand what you're trying to review. Once you have that template in place, when you create a new pull request, it'll look something like this. So this is essentially generated off that previous Markdown file. And you see it's pre-populated the description with those sections and that kind of starter text. So now when you create that pull request, instead of having to think and remember all the things that you should add to set yourself up for success, you just kind of fill in the blanks, which takes a lot of that mental load off and increases the likelihood of actually going through that effort. Now, similarly, you can do this for issue templates. This is really useful for like open source projects as well, where you want people to contribute issues and feature requests, but a lot of times they're maybe not giving you the context or the information you need to really take actions on those. So quite similar to the other template, we can create more Markdown files here. In this case, specifically in .github/issue templates. And then we can define what we want that template to look like. So here we've defined a bug report and some steps we need right there to fix that bug. Here we've defined a feature request. Nothing particularly special about this other than maybe the metadata at the top there. But now once we create a new issue within GitHub, we have these templates to choose from. And so we can help guide people into giving us the correct information we need to make the project successful. And again, like with the pull request, with those templates in place, when they create that issue, that information is pre-populated and they can just fill that in. And kind of one last thing here, and again, this is applicable to other services, like maybe Jira as well, but it's really convenient if you're using GitHub issues and pull requests and all that to reference your issues with keywords such as closes, fixes, or resolves. And then when that pull request is merged, it will automatically close those issues. And so this is just like one small thing to remove an extra step in that development flow and take one less thing off of your plate. So now this is my favorite part of all of this. You can supercharge your PRs with danger. And I don't mean danger in the sense of you're scared, you run away from something, but danger the tool in the software development sense, which is essentially just this kind of scripting engine that allows you to automate common chores within your build pipeline. With kind of danger integrated in our project, we can do things like add inline code comments, check APK sizes, check for dependency updates, add informational messages. And in a sense, we can really just add a lot of extra metadata or informative information to our pull request that is useful, but often we don't remember on our own. This is an example of what that can look like. So in this case, we have added a warning that says, please fill out the description so I know what I'm supposed to review here. You have 15 dependencies that are out of date. A thank you. So again, just encouraging people, thanking them for their work. Small thing, but I, again, think it's really nice. And in this case at the bottom, we're printing out the size of our APK, of our application. So we're going to walk through some of these examples and see how easy this is to set up. Now, to integrate danger into your project, you have a few kind of implementations to choose from. In this example, we're going to be working with the Ruby implementation, which I've used in a few projects and is quite easy. There's a Kotlin implementation coming soon for any of the Kotlin fans in the room. I don't know that it's quite ready yet, but it's very, very close. But basically for this Ruby implementation, you need to either add or update the gem file of your project with these couple of lines here, and basically kind of install this danger gem. And then we can run through these command line steps towards the bottom here. So you can run bundle install, bundle exec danger init. Essentially at this point, it'll walk you through the setup process to define some of these danger checks and start adding things to your pull requests. Now we need to integrate this with our build. So in the case of GitHub Actions, it looks like this. We have these 3 specific tasks to basically just install the required Ruby dependency, install the bundler, and then actually run danger within your pipeline. So for us, we're running this kind of at the end of our build step so that we can do all of our checks up front and then kind of add these messages as extra metadata at the end. So now you'll have a danger file, which is where you start to define these checks. So to start off, a very simple example is you can just print out a general message. So in this case, we've used the message command and then a string saying thanks. And then we can access metadata about the PR itself. So in this case, github.prauthor gives the username of whoever created the PR. And the result of this is that we get this thanks at, and then that username at the bottom. So this is quite straightforward. We can start to do more interesting things as well, like adding actual conditional logic in this. So in this case, we're using a warn command. And basically we're saying, add a warning if the title includes the string WIP. So it could be whatever pattern you want. But in this case, essentially, if this is a work in progress PR, add a warning here that says this is a work in progress and is not yet ready to merge. So again, this is a little easy thing you can do to notify people on your team, hey, don't worry about reviewing this yet. And we could do other logical things as well, and we'll see an example of that later. So another one here is we can basically get access to the file system of our build machine in this case. So once we've built our Android application, we can check the file size there and just add a message that says, hey, the release size of our application is X, whatever. And this is a small thing, but actually just having that visible in every single PR goes a long ways towards mentally tracking changes in size. By just adding this, we've been able to catch multiple regressions where our APK grew in size because we didn't compress some images or something. And you can take this even further, which I don't show here, but there are examples online of how to do it, where you can actually then store this size somewhere and then compare between builds and then notify more strongly, maybe, if your APK changes by a certain percentage. Again, here's another example of checking some type of logic. So in this case, we're saying if our PR description is too short, add a warning to encourage them to give you more information. This is another interesting one here, where we are adding a warning saying, hey, you have X number of dependencies out of date. Now with this one, we're making this possible by leveraging this Gradle plugin, which essentially just will go through all of our project dependencies and look for newer versions. We integrate that into our build script by adding that dependency updates command. And then in our danger file, we can start to add some fairly complex logic here, where we count the number of files in the output, and then we change the output message depending on that. So in cases where there's not that many updates to report on, we might show this, just a single, excuse me, if we have a lot of dependencies to update, we might just collapse that into a single message so it doesn't take up too much space. But if we have a lot, we might do something like this, where you can start to see each individual one. Now, I gave this talk earlier this year, and someone pointed out, well, hey, you might not want to run this every single time because you're probably not going to go and update your dependencies every time you create a PR and see this list. So what we could do is actually create a new workflow that runs on a schedule, let's say in this case, every morning at 8 a.m., that runs this check for us. And this is a nice example of a scheduled trigger with a GitHub action. And you could do similar things with any build server system. But this is just using regular kind of cron scheduling syntax, and then you could define the same steps here. So now, instead of doing that every time we create a PR, we could just do that once a day and then report that out to whoever we would like. And now this one is really cool as well. Earlier we were doing lint checks to validate the code formatting of our project. The problem with that, though, is that if that does fail on the server, you now have to go into the build logs and scroll through output to see what failed and why, which is okay, but that can be fairly cumbersome. It adds quite a few clicks. With Danger, we can actually convert those individual errors from the output into inline comments by a bot. This makes it feel like someone is actually commenting on those directly, like you would in regular code review, except it's a bot. So it's a lot harder to get mad at the bot if it comes back with 50 formatting issues. And then you don't kind of have that resentment towards your teammate who suddenly decided to comment on all of your spacing issues. So to do something like this, we'll add another sort of Danger plugin here that basically just knows how to read a check style format. And then we can point that to the output file in our Danger file. So in this case, very basic Android app, I have a single module, so I point to a single file. If you had a multi-module project, you would need to write a script to combine all those outputs into a single file to read, which is fairly easy to do, and there are examples online of how to do that. And kind of lastly, another kind of pro tip if you're going to do this idea of inline commenting with Danger, if you have 100 lint issues in your project, and you touch one file that has a lint issue, you don't want to be on the hook for fixing all 100 of those. So you can add this line to the top of your danger file, which will basically ignore anything outside the scope of the diff so that it only adds inline comments for whatever you've already touched, which is really helpful. It's very unnerving when you suddenly see all these issues that you didn't touch. And so that was just a small taste of what you can do with Danger. You could do other things like Android Lint. If you're in the Android space, you could report on your test coverage, look for string translations, changes in APK size, all of that. Really encourage you to check that out because it's a very powerful tool. And now finally, we're getting towards the end here. So we're going to look at finally deploying this app we've been working so hard on. Now we have a couple options here. You could do a daily build where just once a day at a certain time, you're going to send that build off to whoever. Maybe a scheduled build where it's once every 2 weeks, just whatever you have in master automatically gets released to testers or users. A trigger build, that could be in response to, a merge or something. Or you could be living the YOLO life where you just generate a build whenever someone asks for one, and then you manually hand that out to whoever needs it. I've been there. It's, you got to start somewhere, but hopefully this talk maybe has encouraged you to move away from that if that's where you're still at. And so kind of building on this, we can think of customized deployment. So specifically, we're going to look at 2 examples of basically on a merge to develop, we're going to distribute to our testers, and on a merge to master, upload our app to the Play Store. So this is actually quite simple. Again, we're going to create a new workflow here called deploy debug. And basically it says on a push to develop, assemble the debug version of our application, and then run the Crashalytics upload distribution debug Gradle task. And basically that task knows how to take that generated artifact and distribute it to testers. So now, by simply merging into develop, we're distributing a testable build to our beta testers. And to make that even easier, we've automated the release notes for that by looking at the Git history. And we basically create a text string from that Git history and attach that to the artifact so that when they open that up in the Beta by Crashalytics app, they see that history and they know what they're testing. And now similarly to deploy to release, on a merge to master, we run the assemble release task, and then we run the publish release APK task, which knows how to publish to the Play Store for us. And that's made possible by the Gradle Play Publisher plugin. This is really awesome because it allows you to store all of your Play Store info as artifacts within your repository. So now, anytime you want to change a Play Store listing or an asset or something, you can change it in your code, so now you can track it. And then anytime you want to release to users, you simply merge to master. And for us, this has been huge. It's taken so much friction out of releasing that now it gets you much closer to that continuous release pipeline. So you can release as much as you want. If people are testing, finding an issue, you simply put a new merge in and automatically is released again. You don't have to waste all your day managing those builds and releases. So it's very helpful. It also makes it so that people can come in day one, merge the code, and release, which is a huge win for new people on your team and really helps them feel good about coming into your project. And so that's kind of it here. We covered a lot of ground, a lot of different things, some big, some quite small. But hopefully, again, we've looked at some of these phases that we can all relate to and hopefully kind of inspired some ways to maybe think about improving our processes and saving us time and energy. And so kind of in closing here, again, I just want to touch on this idea of, think about where you're losing time, energy, or joy to some task in your day-to-day process. It could be, documenting things, enforcing coding standards, releasing to users, really anything. And just think about how you could automate that or ways to make that simpler. Because even small wins can really add up over time. So again, a couple repositories here that have a lot of these examples if you want to look at them and maybe try adding them to your project. Have a list of resources here, blog posts, documentation that kind of talk through more of this stuff. And then just a special thanks to a few people here that either helped write some of this code or had blog posts that showed some of this, by taking a lot of this stuff, incorporating it to our project at PicSite. Ryan and I have gotten a lot of nice wins. And so just shout out to those guys right there. And with that, thank you so much, everybody, for coming and for sitting on the floor, standing, all that. Very appreciative. And if you want to stay in touch with me afterwards, pretty much N8 Ebel everywhere online. If you see me around, I'll be here. Love to chat, love to hear about cool automations or anything that you're using in your projects. Thank you.